So for today, we're talking about the Bouncy+Ball+Lab. Would you agree that a ball won't keep bouncing forever? It theoretically would. Like, wouldn't you think it's going to have to bounce, let's say, halfway back up? And then when it bounces again, it goes halfway back up again? Bounces again, goes halfway back up again? Wouldn't it theoretically keep bouncing forever? Half, and then never stop? You'd think so, but then in the reality, in the real world, does the ball actually keep bouncing forever? No. It's a similar concept to me being able to get out the door. Got to go halfway, then halfway, and then halfway, but I do get out the door. So it's like infinity, but yet infinity, when you extend it out, the concept is where does it converge? Where does the set of numbers start to converge? So let's just do one of those again. Let's say it starts with a half, and then it goes half of that, which is 1/4, and then it goes half of that, which is what? What's half of 1/4? 1/8, comma, dot, dot, dot. That is an infinite series. It's an infinite geometric series. Would you please write down the formula that is used for that? Now we're going to talk about why a ball bouncing is similar but different. Robbie, do you see it on the board there?
Yeah.
Can you read it to me?
Yeah. A is 0 over 1 minus rate,
Yep.
which is 1/2.
Yep. Well, what's A0?
1/2.
Yep. So the sum, when you add it up to infinity, will be A0, which was 1/2, over 1 minus a half, which is a half over a half, which is equal to 1. Does that mean that perfectly models the ball problem? No, it doesn't. Why is it different than that? If it starts at 1 meter, bounces up to a half a meter, and then goes back down again, and then goes up a half of that and back down again. All right. So I'd like you to turn and talk to the person next to you about how the ball is different than this. Why would this not work for the ball? Remember, it's a bouncing ball, and we're talking about how far the ball goes.
Oh, yeah.
All right, so if the ball had started at 1 meter, if the ball had started at 1 meter up off the ground, what would the first number have been? If the ball had been 1 meter off the ground, how far would it have dropped? 1. I heard somebody say it. Yeah, 1. So that's one way that this isn't right. It would have started with a 1. But then it would have gone to a half and a 1/4, and but that's not how far the ball traveled. When the ball dropped, it went 1 down. I'd like you to start drawing a picture of this. Okay, so it drops down 1 meter. Then how far does it really travel next? If it bounces up halfway. Yes.
That travels another 1.
If you count up is a half and down is a half. 1/2 and 1/2. That makes sense to you? Goes up a half meter, then goes back down a half meter. And then for each bounce after that, do you get there's 2 of them? All right. So, goes up and down a half again. Now it's not a half, it's a 1/4. But it's 2/4 because it has to go back down again. All right, so if we actually made a list of what happens in the ball problem, you start with a 1, and then you add to it a half, because that's this first part of the up, and then you have another half, going back down again, and then it's a fourth, and then it's another fourth. So it's definitely different. All right, so that was a little too simplistic because in the real world, this ball doesn't go exactly a half. Now, as I'm holding it here, I've got the ball, I've got the stick, it's a meter stick, and I'm dropping it from, well, where should I drop it from? Just anywhere near this top? No, that makes a big difference. Should it be sitting on top of the ruler when I drop it, or should it be like in the middle of the ball, or should it be at the top of the ball when I drop it? So like having it sit on top of the ruler here,
Then it falls 1 full meter.
that way the bottom of the ball is what actually hits the ground, right? So the bottom of the ball has to start at 1 meter, so I can do that. All right, now I want you to just watch with your naked eye, and I'll put it up on this desktop here, and it's gonna tilt it, which is gonna throw it off a little bit, so we will prop that up with, here, actually, would you hold that edge of the desk up just a little bit, just so you're gonna lift it up with your hands until it's, so we can get a bounce that goes pretty much straight up. That's close. Okay, a little higher. That's about right. Okay, keep it right there. And you can actually set it down to rest your hands, but we'll put it back up there in a second. Now, we're gonna have to have it get recorded with an iPad. Okay, and then that will be able to tell us exactly how high this thing is bouncing up. You know what I mean? If we record it with an iPad, then when we replay it, we'll be able to tell, the speed of the ball doesn't matter. We could theoretically get the speed of the ball from the iPad, because we can go how far it went in how much time, right? But all we really care about is how far is it actually bouncing back up again. All right. So I'm gonna have Alec use his iPad, he's got a pretty good angle there. And you're gonna hit record before I drop the ball, okay? And then you can lift it back up again to stabilize this desktop. And then I'm gonna drop it, and you need to be able to hit record now. Okay, you stop it. Now, go into your iPad, picture, or hit the video and make it play, and scrub it until you can get where the ball went to its absolute peak. Because it wasn't a half a meter. It was actually 100 centimeters is what it dropped first. Let's change everything into centimeters, because it'll be so much easier, believe me. Otherwise you have weird parts of meters running around. So 100 centimeters was its initial drop, and it didn't actually come back up a half. Alec, can you tell us what did it come up to? Remember, we're looking at the bottom of the ball.
I guess I draw the line.
And I know it's kind of, you know, like this is going to be off a little bit because the ball didn't bounce perfectly straight up. Balls don't do that in the real world. They don't drop perfect.
I think it was 53.
53 centimeters, thank you. Actually, let's use 54. If you're kind of guessing, I'd rather use 54. You know why? Because it's an even number. Is it actually closer to 54? Or is it closer to 52?
I think closer to 54.
Okay, perfect. So let's go with 54. Then, as now I know when it drops, it's gonna be the same as that, right? So then it'd be 54. And then when it goes back down again, you can make a prediction of where it's gonna bounce back up, right? That'll take a little bit of math. All right, you've got all your data. Your lab is mostly done. It's kind of like a lab, but really abbreviated, because now you know it's bouncing, your ball is bouncing up a little more than halfway. 54 out of 100 you should be able to tell what the next ones are, and then you should be able to figure out how much this thing actually adds up to. The grand total, 100 plus 54 plus 54 plus etc. But do you really want to find like 1,000 terms of this and add them all up? No. You're probably going to want to use this formula right here, and then you'll be able to add them all up. But there's doubles, and you'll have to deal with that. It's not that hard. All right, you have a partner for this lab. And these two rows, you're gonna slide next to each other. Go ahead and do that. These two rows, slide out in the back. Here, we'll have a perfect partner for everybody. Slide next to each
So
other.
you get the number 154, right?
4, 7. I'm fine with whatever, but we just divide those into two,
Don't know how.
Don't use,
2s and 1 3.
this formula for find the
Two is we can use
By the next one? Yeah, I was kind of like,
2 and moving the back. So then how about?
You already did it.
No.
I think I know how to do it. Slide
Are you doing the rate as 54 over 100?
Okay, then we got that.
oh yeah, that's what it
Okay, now you got your groups. So the first thing you need to do is, this is actually going to be a lab. What you did before, that was scratch work, okay? But you can use these numbers, where it starts with a 100 centimeter drop, and then it comes back up 54, okay? And then it goes back down again 54. So that's your data, all right? So start with a blank notability doc, everybody, and then write purpose. What is the purpose? Well, it is to figure out, and you can't use my exact words, but it's to figure out how far total this ball will travel when it's been dropped. What's the total distance it'll travel? How many centimeters does this thing actually go? It starts with 100, adds 54, adds another 54, and then you can actually do this. You can actually get the final answer. So get your purpose written in your own words, and then go through and answer the rest of the questions. By the end of the hour, you should be able to be done, and you should be able to turn it in all today, and you can just be done. Because we're just going to do this as a one-day shot, and we're kind of doing it together, it won't be graded like a normal lab, but it will count in your grade. So do your best. And I'm going to pause this just in case there's more good questions that come up between now and the end of the hour. All right, so remember, you got to have a purpose statement. You got to have a sketch. Can you sketch this ball going back, bouncing and back up and down and up and down? Sure, you could sketch that. You could label the sketch. You can have a purpose, you can have a procedure, which is, remember, where you like say, here's what we did. I already did a bunch of things. You can type that up as a procedure. We started by dropping the ball, and then we measured how far it came back up using an iPad, and then we blah, blah, blah. So that's procedures. You say in words what you did. The last part is calculations, and then you kind of reflect on what's the math involved here and what you like about it and what you could make different. And then you have to have a conclusion, which is the answer to the question. Don't forget that in the conclusion needs to be the answer to your original thing, which was, I want to figure out how far the ball dropped. All right, so there's my advice on this lab. And that's all I got for you, unless we come up with some good questions. Okay, so now that you got the lab kind of figured out with the numbers 100 and 54 and 54, your numbers aren't actually going to be 100 and 54 and 54. They are going to start with 100, because everybody will drop their ball from 100. But your number won't be 54, okay? So yeah, you're going to go back and erase those, but it'll be really easy. It's the same exact numbers. Don't erase your whole lab at all. You've got most of it figured out. It's just some of your numbers are going to change. Like, let's say yours actually bounces to 48, and then this will be 48. And then that's all you really need. And then I'm assuming you found the ratio, right? The R. What was your R before? 54 out of 100. Well, now it won't be 54. It'll be like 48 out of 100. All right, so I want you to actually have this experience. So send one person from each group up to get a ruler and a ball. Rápido, por favor. One person from each group. I have another. And as soon as another ruler becomes available, I'll get you guys another ruler in just a minute. You could, once you're done with your ruler, would you please bring it back up quick? I have one more ruler.
Yeah, 52.
We get the time thing this also, right?
The time actually doesn't matter, it's just how high did it bounce. Remember, you're watching the bottom of the ball. Back far enough so that there's no chance that you miss it. Not very way back.
It's not a film line.
Alright.
You see everything? Alright, good.
Yeah.
Alright. And at least they got the indentations kind of right.
Once you're done with the ruler, just bring it back up, make sure you got data. If you have questions, bring them up, I'll help you.
Bro, they like kind of like this line.
You guys have my permission to take your number and round it to an even number that's closest. Because your life will be a lot easier. In other words, if it's 37.5, call it 38. You know, because you want it to be an even number. Need to borrow an extra ruler. I got rulers, I got balls up here, I got everything you need. For those at home, remember that the ball is held up to the ruler so that the bottom of the ball is at the top of the ruler. And it drops 1 meter, and then you measure to the bottom of the ball and see how much it bounced back up again. Let's say this is 37.5, you can round that to 38. This isn't super accurate anyway, so. Okay, I was asked a good question about sigma notation. Here's an example of somebody adding up from 2 to 10 of, let's say, the formula for this thing was A0 plus, this is not the right formula, by the way, where you added something each time. This is kind of what they're talking about with sigma notation, except this doesn't go from 2 to 10. I told you to always start with 1, and this one's an infinite series, okay? And you have to figure out what to put here, but that's what they mean by sigma notation. Again, trying to be vague so you can do this yourself. Okay, I know we're getting a lot of people closer to this because now people are starting to know that it goes from 1 to infinity. That's good. And now people are figuring out which formula it is, and it's not that one. But now people are concerned with this. They get it to come out with 100, and then let's say it was 54. It wasn't, because you can't use that number because that was just the tennis ball I used. So, but I'm going to use it so that you can have that example. Would your sigma actually come out with another 54? No, there's no way to do that. You can't have another number like 1, 2, this is putting in 1, this is putting in 2, and you can't get it to, when you put in 3, still come out with 54. There's no way to do that. So what's half of 54? It's 27, honors class. Half of 54, you can't do that. Anyways, I get it, under pressure. But so imagine for a moment that you had to keep going like this. Notice I'm skipping all the repeats. There's no way to get it to repeat. You can't put in a bigger number and have it come out with another 27. You can't do that. There's no way to do that. So don't try to make that happen. So it's almost like I'm ignoring all the bounces, isn't it? It's like I started with 100, then went to 54, then went to 27, and then I will do half of 27. So half of 20 is 10, half of 7 is 3.5, so that's 13.5. And then, look at that, I'm just ignoring all the bounces. Yeah, that's kind of this lab. You kind of ignore the bounces until you have to, like, figure out the final answer at the end. All right, so your sigma has got to replicate this, except not 54, because yours actually had a different bounce ratio than that. All right, that was a good question. And that was all of the good questions I had for the lab, and so that's all I have for the video for today.